Hello everyone, my name is Franco Pucci and I am the technical consultant for the STS Association. I've been involved in the prepayment industry for over 25 years. Welcome to the STSA training video series where we will explore all aspects of the STS and the STS standard. I hope you find these videos helpful. So in this video we will deal with the IEC 62055-41 application layer protocol, and it's specifically on section 6, data elements of the APDU. The reference source, of course, is the IEC 62055-41 document. So let's have a look at token definitions, which are in clause 6.2. The first one we're looking at is class 0 in 6.2.1, and the subclasses are shown below. So the class is 2 bits, the subclass is 4 bits, the random number is 4 bits, token identifier is 24 bits, the amount is 16 bits, and the cyclic redundancy checksum is 16 bits, giving a total of 66 bits for the token. The class you can find reference to in 6.3.2 in the IEC 62055-41 document. The subclass 6.3.3, the random number 6.3.4, the token identifier or TID in 6.3.5, the amount in 6.3.6, and the CRC and also the CRC for currency in clause 6.3.7. We'll look further at these token fields later on or in a later video. So let's have a look at class 0, the transfer credit token. That's in clause 6.2.2. This consists of a class, 2 bits, and that's a class 0. So both 2 bits are at 0. The subclass is 4 bits, with a 0 being electricity, a 1 being water, a 2 being gas, and a 3 being time. And of course the random number is 4 bits, the token ID is 24, the amount 16 bits, and the CRC 16 bits. Then for currency we have exactly the same thing. You have the classes class 0, the subclass is 4 for electricity currency, 5 for water currency, 6 for gas currency, 7 for time currency, and 8 to 15 are not assigned. You will notice that the CRC on the right hand side for units and for currency are different. The units one is a standard CRC and the currency one is a CRC_C, which is different to the CRC above, but we will discuss this at a later time. Then you have class 1. Those are explained in 6.2.3, and this is an initiate meter test token. That is a class 1 token. Subclass 0 is a bit position control of test display. For 2-digit manufacturer codes you use 36 bits in the control, and the manufacturer code you use 8 bits. For subclass of 1 you use 4. For 4-digit manufacturer codes you use 28 bits. Okay, so the first one, subclass 0, is for 2-digit manufacturer codes and you would use 36 bits in the control field. Subclass 1 is for 4-digit manufacturer codes and you would use 28 bits in the control field. Subclasses 2 to 5 are reserved by the STS Association and not assigned yet. Subclasses 6 to 10 are proprietary subclasses for 4-digit manufacturer code meters. If it's not used, you can set it to 0. The manufacturer codes in this case are from 0100 to 9999. Subclasses 11 to 15 are proprietary for 2-digit manufacturer code meters, set it to 0 if not used. And the manufacturer code range in this case is from 00 to 99. Class 1 tokens are not encrypted and can be used as many times as you like in a meter. Therefore, there is no TID required, as you may have noticed. These can be hard-coded into the vending software, so every time you want one, you don't actually encrypt anything, because the security module can't even support encryption of these tokens, simply because they are not encrypted. Next, we look at set power limit, and that's in 6.2.4. Again, the token is made up in exactly the same way. You do have a token identifier in this case. The class is a class 2, subclass 0, and the power limit is 16 bits and the limit is in watts. The action in this case is to set the power limit of the meter to the value in the power limit field. Then you have a clear credit token, which is 6.2.5 in the IEC document. It's a class 2 subclass 1 in this case. Again, you have a TID, and then instead of the power limit field you have a register field that is 16 bits, and that denotes which register you want to clear. The action in this case is to clear the credit in the register specified, and that's registers 0 to 7 or 65535. Let's have a look at those. Okay, so register 0 in that field would mean clear the electricity credit only. Register 1 is for water, register 2 for gas, and register 3 for time. Register 4, 5, 6 and 7 are for all the currency registers. That's electricity, water, gas and time. Registers 8 to FFFE, hexadecimal, are reserved for future assignment and should not be used. And if you put in a value of FFFF in hex, which is 65535 in decimal, then that clears all the registers in the meter. Next, we have the set tariff rate, which is in 6.2.6, and that's part of the management tokens as well. And over there you can set the rate on the right hand side, which is 16 bits. This sets the tariff rate of the meter to the value in the rate field, but this subclass is reserved by the STS Association and is currently not used. Clear tamper, subclass 5, class 2, and what this one will do is it will clear the tamper register in the meter and cancel any tamper control processes that may be going on at the moment. Next, we have a set phase power unbalance, which is 6.2.10. Okay, and the maximum phase power unbalance limit is 16 bits. So what that does is loads the maximum phase power unbalance limit into the meter. The set water meter factor 6.2.11 is subclass 5, and the water meter factor is set using those 16 bits. And this token is reserved by the STS Association, so it should not be used. And then you have reserve tokens. This is 6.2.12. That reserve data, res data there, 16 bits, currently not used and reserved by the STS Association. So these tokens should not be used. And you also have class 3. The entire class, subclasses 0 to 15 are reserved by the STS Association. Then you have subclasses 11 to 15 in the class 2, and these are reserved for proprietary use. And if you want to have a look at those, you can refer to 6.2.13. In this case, you can essentially put anything you like in the proprietary data. However, please note that there is no protection for collision between manufacturers in this token space. The contents and action are under the direct control of the manufacturer. In the next video, we'll be looking at key change tokens. This brings us to the end of this part of the video series. I hope you found this video helpful and hope you will join us for the rest of the series. Goodbye and see you again soon.